chemistry that deals with the study of carbon compounds. It's the study of carbon compounds. Carbon compounds. So when we said carbon compound, it means organic chemistry is the chemistry that deals with the study of compounds that contain carbon, although there are some exceptions. But generally, whenever we said organic chemistry, it means it's the chemistry that deals with the study of carbon and its compound. And when we said carbon and its compound, it means that any compound that contains carbon is an organic compound. So in a general term, organic chemistry is a branch of chemistry that deals with the study of carbon and its compound. And although there are some exceptions, we have some compounds that contain carbon, but they are not organic. So I will give you this exception, that whenever you see any compound that contain carbon, but if they are not actually those compounds that are accepted, it means that they are all considered as organic compound. So I'm now going to start with the exception, that whenever you have compounds, whenever you have something like this, one metallic carbonate, sorry, metallic carbides. What is metallic carbides? It means that whenever you see a compound that contains carbon and metal, that compound is not considered as organic compound. Like for example, if we said calcium carbide, you see in this case we have calcium and carbon. So this is a typical example of metallic carbides. So whenever you have a carbon with a metal atom, that compound, even though it contains carbon, but it is not considered as organic compound. Then in addition, if you have, let's say, sodium carbides, magnesium carbides. So if you look at all this, you will see that they are compounds that contain carbon, but this is one of the exceptions, that they are compounds that contain carbon, but they are not considered as organic compound. So I'm not going to list them. So if I list them, so whenever you are actually doing organic chemistry, and if you saw those kinds of compounds that contain carbon, but you will not consider them as an organic compound. And then second, apart from this, you also have metallic cyanides. Metallic cyanides. When we said metallic cyanide, it means that they are compounds that even though they have carbon in them, but they are not considered as an organic compound. An example of this metallic cyanide is when we have something like potassium cyanide. A cyanide stands for Cn. Cn is cyanide. So when you have metal and cyanide together, although if you look at it here, you will see that we have carbon, but it is not considered as organic compound. So also we can have sodium cyanides. We can also have hydrogen cyanides. So they are all compounds that if you see that in them they have carbon, but they are not considered as an organic compound. And then apart from this, the second compounds that contain carbon but not considered as an organic is metallic trioxocarbonates. Metallic trioxocarbonates. Example of metallic trioxocarbonates, we have like sodium trioxocarbonate 4, or we can have calcium trioxocarbonate 4. So these ones, they are also compounds that they have carbon in them, but they are also not considered as an organic compound. So this is the third one. And the fourth one, which is also the last one, the fourth one, which is also the last one, is carbon dioxide and carbon monoxide, that is CO. So carbon dioxide and carbon monoxide, they are also compounds that they contain carbon, but they are not considered as organic compound. So ladies and gentlemen, these are the 4 classes of compound that they contain carbon, but they are not considered as an organic compound. But apart from this, any compound you see that contain carbon in them, you can consider that compound as an organic compound, except these ones. And then the next thing, I hope is clear. Is that clear? Okay.
Yes, sir.
Okay. So now the next thing that we are going to look at is what are the elements that are considered or that are mostly found in organic chemistry. The elements that are found in organic chemistry, that is what we are going to look at. So actually we have the following elements that are considered in organic chemistry. The elements that are found in organic chemistry, we have something like elements found in organic compounds. In organic compounds. So number 1, we have the main element. There is a main element that are found in organic chemistry. There is a main element, and this main element is carbon. We have carbon as a main element. And second, we have halogens. We have halogens. Halogens, they are X. We consider them as X, and this X can be chlorine, it can be bromine, it can be iodine, it can be fluorine, it can be astatine. So these are the group of elements that are found in organic chemistry. The main element, which is carbon, halogens, which include chlorine, bromine, iodine, fluorine, and the rest. And then we also have, apart from halogens, we also have hydrogen. Hydrogen is also one of the major elements that is found in organic chemistry. And then apart from this, which is apart from hydrogen, we have number 4. We also have sulfur, nitrogen, and oxygen. So these are actually some of the elements that are mostly found in organic chemistry. So now, we said the main element is carbon. So why carbon is considered as a main element in organic chemistry? We are going to look at why carbon is considered as a main element in organic chemistry. Number 1, carbon has the ability to form single bond. It has the ability to form single bond. It can form single bond. It can also form double bond. as well as a triple bond, as well as triple bond. So it means that in a simple term, carbon have the ability to form what you call a multiple bond. Multiple bond. So that is one of the main reasons why carbon is considered as a main element. It has the ability to form multiple bonds. And this multiple bond includes single bond, double bond. We have single bond, double bond, and triple bond. So it means that in a carbon, you can have carbon to have single bond, or it can form double bond or triple bond. So carbon is considered as a main element in organic chemistry because it forms, or it has the ability to form, multiple bonds. And this multiple bond can be single bond, double bond, or triple bond. And now the next thing also, we are going to look at another reason why carbon is considered as a main element in organic chemistry. Why carbon is considered as a main element in organic chemistry. So the other reason is catenation. Catenation. What is catenation? Catenation is the ability of an element to form long chain. Is the ability of an element to link itself to form long chain. And this long chain can be in the form of something like this. Like carbon can form a very long chain. So that is catenation. So it has the ability to form long chain as well as branch chain. So carbon is the only element that have the ability to form long chain and branch chain, and that is the meaning of catenation. So carbon is considered as a main element because it has the ability to form multiple bond and also catenation. That is the second reason why carbon is considered as a main element in organic chemistry. And then what is also the other reason why carbon is considered as a main element in organic chemistry? The other reason is why carbon is considered as second, catenation, and the third reason why carbon is considered as a main element is it has the ability to form, it has the ability to undergo four different, it has the ability to form four covalency. So it has the ability to form four covalency or strong covalent bonding. It has the ability to form, strong covalent bond. Strong covalent bond. So that is the third reason why carbon is considered as a main element in organic chemistry. It has the ability to form strong covalent bond. And why do we say that it has the ability to form strong covalent bond? Of course, if you can remember when we said covalent bonding, it means it's the types of bond that involve sharing of electrons. It involves sharing of electrons between atoms to form a molecule. So of course, if you consider carbon, the atomic number of carbon is 6. So it means that it has 2 electrons on its first shell, and then on the second shell, there are 4 electrons. So you have 1, 2, 3, 4. So it means that we have 4 electrons here. So it means that one atoms, like for example, one atoms of hydrogen can actually share one electrons with one of the electrons of carbon, and also it can form another bond. It will share another electrons with hydrogen here, and then also another atoms of hydrogen can share electrons with carbon here.
Yeah.
So also at the
So
same
also
time,
at the same time,
one electrons will
one
also
electrons will cross.
also another one electrons will be shared here. So at the end you will see that there is carbon shared four of its electron. So the more the number of electrons shared by a particular atom, the stronger the covalent bond is. So if you see that in carbon is one of the elements that shared the highest number of electrons. And as a result of that, it undergoes strong covalent bond. And that's what makes the atom stick together. So as a result of this, we'll understand that because four electrons are shared by carbon atoms, it means that it undergo four covalency. It undergo four covalency. It undergoes four covalency. Okay, it's like someone is having question. A. Ibrahim, you can ask your question.